Hello, today we're going to be talking about bit shifting. All right. So, what is bit shifting? Well, you have two forms of bit shifting. You have either a logical shift or an arithmetic shift. And in those, you can either logically or arithmetically shift left or shift right. With logical shifts, you will have a 0 being entered in either from the left or from the right, depending on which direction you are shifting by. And with arithmetic shift, you're going to always make sure that the sign, no matter which way you're shifting, your sign remains whatever it was beforehand. So if it was a 1, meaning likely a negative value is a negative value, then we have to make sure that we input 1s so that the sign is always still negative. So let's go ahead and show you how this works. So here we have an input of, I believe is 10. We have an 8 and a 2 here, and it's going into this shift left or right. We could choose left or right based on this button here. And as you can see, we have it set to 0, which is a right shift. So 1, 0, 1, 0 outputs to be 0, 1, 0, 1. You can see these ones kind of shift over a bit. Now, if we were to shift to the left by turning this to 1, you can see that these bits get scooted over by one place to the left. And here we have this shift over bit here, 1, 0, 1, and then 0, zeros get filled in. So this is a logical shift. And what it's doing is either by shifting right, you are dividing, and by shifting left, you are multiplying. So as you can see, we have a 10 here, and we increment by 2. We have 16 here, and then a 4 here, which makes 20. So we're multiplying of multiples of 2. So that's how that works. Let's go ahead and show you really what's going on deeper down within. We have multiplexers, 2 to 1 specifically, doing all of our work for us, okay? And you can see that A0, A1, A2, and A3 gets plugged into this D1 spot. So that if we hit on, A0 will just come out to the Q1 spot. A1 will come out to the Q2 spot. It's shifting over to the left, right? Now, if we have this set to 0, then what happens is, for example, our A1, which has a 1, instead of going through this D1 input here, it's confusing because this A3 is going into this D0, and that's what's being selected and outputting 1 here. But this A1 here is coming out and coming into this input here and being accepted to be outputted. So in that case, everything gets shifted to the right. So I try to line things up as best as I can so you could see the shift going on, but it's always best to look at A3 and Q3 and see if that moves up to the shift over space and all of that. So multiplexers, they really help us out here. Okay, now let's go a little bit more advanced. This is same exact concept, but we just expand on it a little bit more. So not only are we shifting left or shifting right, but we also have an option that is for no change and what should be a shift right arithmetic mode. But right now that is not set up. It is set up to just be undefined for the time being. But I'll go ahead and show you how it works. So, excuse me, this is not the right one. This is the right one. Right, so here is what we have. We have an input of 1, 0, 1, 0 here, okay? And when none of these selector switches are turned on, we should have a shift left. And you can see we do. The 1 in the most significant bit gets shifted over to here, and this bit gets shifted over one spot too as well. So 1, 0, 1, 0 becomes 1, 0, 1, 0, 0, which is also 20. And when we turn this one on, we have no change. As you can see, 1, 0, 1, 0 is just outputted to be 1, 0, 1, 0. Pretty cool. If we have S1 selected on, this is our shift right logical. And then when you have both of them turn on, then it is what I believe undefined. So really nothing happens. No definition. We could see how this works if we open this up, you could see here for this to work, we use 4-to-1 multiplexers, okay? And it works very similar as to the 2-to-1 multiplexers, just a little bit more on a complicated scale. Multiplexers are very important for bit shifting because we can have two inputs and compare those inputs with one another with a selection and choose which one we want to output. So we can have one of these inputs go into its respective output for no change, or you can have it sent A2 into A3's output or A1's output, and based on the flip of a switch, you can have them go to different outputs, and that represents basically bit shifting. So that is all, and thank you for watching.